Let us look at one more example to understand the simplification of CFG. As always, let's look for epsilon productions and then try removing them. On the simplified grammar, remove unit productions followed by removal of useless symbols. And in the process, we should ensure that suppose this is G, L of G must be same as L of G prime. And what is G prime? G prime is G minus epsilon, and this must be same as L of G double prime. This is G prime minus unit productions, and this must be same as L of G triple prime, and this one is G double prime minus useless symbols, productions, all that, right? So the language accepted by the given grammar, that must be preserved across all. Okay, so now let's look at this. You find that H implies JHD, so which means H implies JHD. One can also apply epsilon, means we get JE. And do we find H in any other place over here? So which means S implies GH or S implies G. Fine. And that's all. Wherever H is appearing, we should ensure that that production you substitute epsilon before you remove this. Okay, now let's look at this. Now see, wherever G is appearing, we say S implies GH or H, and G implies CGB or CB, and G is not appearing in any other place. So which means the simplified one after removing epsilon productions are S implies ESE, or you get GH or G or H. Then you have G implies CGB or CB. Then you look at H. H implies JHD or JD. Then J implies BJ. J implies F. Okay, so this would be the first step, and this clearly says there is no epsilon, and this grammar is equivalent to G. Fine. Now let's go for the next one, wherein we remove the unit productions. Now the unit productions are S implies G and S implies H, and subsequently we find G implies this and H implies this. So which means before we remove, we should ensure these productions are taken care of. So S implies ESC, GH, and S implies G, G implies CGB. So we get CGB or CB, or we get S implies H. So S implies H, H implies JHD or JD. And other productions are G implies CGB or CB, and H implies JHD or JD, J implies BJ, J implies F. Fine. So the two unit productions are S implies H and S implies G, and both are removed, and instead the transitive relation S implies G, G implies CGB, that is written. Similarly, S implies G, G implies CB, that's also written. The next two ones are S implies H, H implies this, S implies H, H implies JD, so that's also written. Fine. Now on this, we should identify useless symbols, productions, terminals, non-terminals that cannot be reached, and strings that cannot be generated following some production, all that can be removed. Let's look at one by one. S imply ESE. Yes, one can recursively apply this, and RGH, and from GH I can take this and recursively apply, and if I want to terminate, I can use G implies CB. For H, I can take JHD, and this can be applied recursively, and if you want to terminate, we can use this. Or one can also apply J implies BJ a couple of times, and if I want to terminate, we can use J imply F. Fine. And same is the case for this CGB, and you can use this and recursively apply couple of times, and before you take a call to terminate using this. Okay, so this shows that from S, of course you can reach S, and you can reach G, H, and subsequently from G you can go here, or you can terminate by using this. From H you can reach J, and through J you can reach F. So which means if you start from S, we will always generate a string over E, J, and J is a non-terminal, so over sigma is E, C, B, D, F. Correct? So we will always generate some string over this alphabet. These two are terminals, C and B are terminals, and J, H, D, D is a terminal, J is a non-terminal. With J you can reach F. So this clearly tells you that all these symbols are useful. So N consists of S, G, H, S of course, G, H, and then J from this, and all these symbols are useful symbols, and all productions are useful symbols, so no need to simplify further. So G triple prime is same as G double prime. Fine. So the first step is to remove epsilon, and on the simplified grammar remove unit productions, and subsequently go for removal of useless symbols, productions, and productions that one cannot reach starting from the start symbol, non-terminals that cannot be reached starting from the start symbol, all that can be removed in this process. Fine. One can also analyze the language accepted by this grammar. Look at this. One can apply ESE any number of times, and that shows that the count of this E and this E will be one and the same. So you apply ESC and again you apply ESE. So which means every time you generate one E here, a corresponding E is also generated. Okay, so the count of this and this will be same. On the similar line, you look at CGB. So you have S implies CGB and look at G implies this. This says C, on this side it's B, and G implies CGB. Again, this implies CGB, and when we want to terminate, we get CB. So that shows that for every C, a corresponding B is also generated. Okay, and one can also terminate using this CB. Okay, so that's also there. Let's look at H. Like these two, H says H implies JHD. Again, this can be replaced as JHDD, which means for every non-terminal J, a corresponding terminal D is generated. And of course, one can terminate using JD, and subsequently using this, one can generate a string out of it. Fine. And if you focus on this, J implies BJ, one can apply this any number of times. BJ, BJ, any number of times. Okay. Now with G you can get something, with H you can get something, and instead of starting from S implies ESE, one can also start from S implies JHD. Okay. So having seen this picture, let's combine and write the language accepted by this grammar. Let's analyze the language based on the discussion we had just now. Look at G. From G we get to see that CGB, and finally you terminate using this, which means we get C power M, B power M, where M is at least 1. And look at H. From H we get to see JHD, again JHD every time. So which means we get something like J power K, D power K, where K is at least 1. But remember, J is a non-terminal, which means from this you may simply get F power K, D power K, or one can also do this. Let's take triple J followed by DDD. I can replace this with BJ, again another BJ. This I may replace with F. This one I replace with BJ, again BJ, again BJ, and finally F. So which means if you look at this, then you get to see something like B square J, say F, followed by F, followed by B cube F. So from this J, you may get something like this. And one can pump any number of B's. It simply says BJ, BJ, BJ so many times, and finally you get F for the last one. and from the first j I may get 1b. From the second one I may get f, no b at all. From third one any number of b's and so on. So which means this one tells you that you may get something like b star f to the power k followed by d power k. Now if it is 0, then you just get f, which is f power k d power k. Or the first one may be bk, second one may be b square f, the third one may be b cube f, and so on. So something like this is possible. So f followed by bf followed by bbf followed by ff, and there are 5, so which means d power 5. Okay, so something like this is possible. Correct? So now from G you get to see this, from H we get to see this. Now the non-terminals apart from the start symbol are G and H. So having analyzed these two, now you can find what can be generated starting from S. So starting from S, the simplest one is CB or CGB, which means C power m, B power m, where m is at least 1. So we may get this, or we use this and pump any number of times, or we may get this union. It is G followed by H. So G gives you C power m, B power m, and H gives you J power k, D power k, but J is actually this. So which means what we get is B star f to the power k followed by this, where m is at least 1 and k is at least 1. So if we take this, then we get this. If we take this, then for G it is this, for H it is this. Or union, look at ESC. ESC tells you that e power n, and this side also e power n. In between you have s power n. But that s power n can be this or can be this. Okay. So which means from this we may get e power n, C power m, B power m, e power n, or e power n, C power m, B power m, B star f to the power k followed by D power k followed by e power n. Correct? So which means E may appear. If it appears, then it could be like this, or it could be like this, because you can replace this S with this part, or you can replace with this part. Correct? Union, S also generates JHD, which means we know this part, which means union B star f to the power k followed by D power k. Fine. So now what is this telling you? The language generated by this grammar, it could be either just C and B, or you get to see Cm, Bm followed by this, okay, or it could be e power n followed by s power n followed by e power n, which means e power n, c power m, b power m, this, or e power n, c power m, b power m followed by this, or it could be this. Okay, now can we combine this further and then write a succinct one with appropriate indices for n, m and k. Okay. So remember, yes, you can terminate using this or you can terminate using this, and these things, of course, finally it will take this or this. Okay. Now let's see whether this can be simplified any further. Note that if we simply say m is at least 0, so that this part will be taken care of, and we say n is at least 0, so that these three will be taken care of, and we say k is at least 0, so that this will be taken care of. But if we do that, then what will happen? We may end up generating empty string, and whereas the empty string is not part of the language. Okay, so to ensure that we don't run into problem, let me write like this for better clarity. So L1 is c power m, b power m, where m is at least 1. L2 is c power m, b power m, b star f to the power k, d power k, where m is at least 1 and k is at least 1. And L3 is e power n, c power m, b power m, e power n, where m and n are at least 1. L4 is e power n, c power m, b power m, b star f to the power k, d power k, e power n, m, k, all are at least 1. And L5 is b star f to the power k, d power k, where k is at least 1. And now what is the language generated by G double prime is precisely L1 union L2 union L3 union L4 union L5. Okay, quite interesting that a systematic way of approaching this problem is also helping us to identify the language generated by this grammar. Let's explore more about CFG.